Hey, what's up, chemists? This Alex topic gives us a single displacement reaction and asks us to design a galvanic cell from it. So in this example, we are given the reaction of zinc and iron chloride going to zinc chloride and iron. And then we're asked to think about an electrochemical cell that might be made from that. And we're asked questions about half reactions. So let's go ahead and we'll get started. And the first thing I want to do is think about this reaction, and let's go through and put some oxidation numbers on these things. So the zinc solid, we're going to give a 0 oxidation number. The iron, we're going to give a +2. The zinc, we're going to give a +2 on the product side, and the iron gets a 0. Chlorine here is a spectator ion, and I'm just not going to worry about spectator ions. Life is too short to worry about spectator ions. So this reaction tells us what happens in this cell and what half reaction goes as a reduction and what half reaction goes as an oxidation. So let's diagram that out. So for our reduction, based on this equation, a reduction is picking up electrons, right? So we're going to have Fe2 plus 2 electrons going to, that's our reduction half reaction. The oxidation is going to be something losing electrons, and the zinc here loses electrons. Zincs to be zinc, they always lose electrons. So zinc going to zinc 2 plus. Okay, so that's what we need from the reaction. So let's see if we can answer some of the questions that are. So first it says write a balanced equation for the half reaction that happens at the cathode. So if we're at the cathode, you should remember that the cathode is always where the reduction takes place. And if you forget that, remember it is a red cat will help you remember that reduction happens at the cathode. So our half reaction for the cathode is going to be the iron. So Fe2 plus 2 electrons. The second question asks about the anode. So which half reaction happens at the anode? And the anode is always the oxidation. And if you need help remembering that, it's anox. So anode is the oxidation. And I like to say that anox stepped on a red cat, but that's just my general dislike of cats coming through. So if we write the balanced half reaction for what happens at the anode, we're going to write the oxidation of zinc here. So we're going to have zinc solid going to zinc 2 plus 2 electrons. And Alex, I think, will probably want you to put in all the phases and all of that stuff. You'll have to take a look. You'll probably want to include aqueous. Whatever is given to you up in the equation, you'll probably want to include in. All right, so what substance is E1 made of? So in E1, on the left-hand side of this cell, we've got the oxidation. We've got zinc solid going to zinc 2 plus 2 electrons. So that means that our solid electrode is, so we can say zinc solid. What substance is E2 made of? That's for the same sort of reasoning, is going to be iron solid, complete. Fe2 plus 2 electrons going to Fe solid, and the electrode then is Fe solid. The solution is Fe2 plus, and we're also going to have Cl minus in the solution. On the other side of the equation, we're going to have zinc 2 plus, and we're going to have Cl minus. So what are the chemical species in solution 1? It's going to be zinc 2 plus and Cl minus, and Fe2 plus S2. You'll probably want to check about whether or not you need to put aqueous indication in there. Probably you will. That's it for this example. Thank you so much.